Welcome to HB Tuners for Gen 2 Coyote Training Part 23. This training module, we're going to be taking a look at how to do some custom programming in our VCT scheduling. So this is going to be a necessity if we've deleted the charge motion valve assemblies. So we've put on, let's say, an 18 plus Gen 3 intake manifold. We've blocked out the charge motion valve assemblies, which a lot of people do. We're going to find the car runs like total crap, and we need to go in and fix it. And the reason why it runs so bad is because it's calling on the incorrect map points and comparing for the charge motion valve assemblies being deleted. So there's a lot of cleanup work that we need to do in order to make sure things are back in line. So we're going to be covering how to deal with that within this training module. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at doing custom VCT schedule programming for our Gen 2 Ford Coyote applications. The focus of this tutorial is going to be, what do we do when we've deleted the charge motion valve assemblies from our intake manifold? This is something that you're going to be running into if you're going forced induction. You would definitely want to get them out because they can start to close as you get in enough boost, even though you've went in and commanded the engine control module here to keep them open with enough boost pressure that actually can start to close themselves and create a whole bunch of issues. So we want to avoid that happening. You also may find that if you're swapping on, let's say, a 2018 plus intake manifold, it's much easier to delete the charge motion valve assemblies, or even a GT350 intake manifold. So we have to do some specific things for the VCT programming, specifically in the distance tables and the array tables, so that we're able to go in and call on our map points 14 through 26 now for the idle and part throttle normal driving situations. We'll find that previously, when we had the charge motion valve assemblies, let's say in your stock intake manifold, and you kept them in place and you have everything functioning with the opening and closing, when the charge motion valve assemblies were closed, we're calling on our map points 0 to 13. When the charge motion valve assemblies were open, we would call on our map points 14 to 26. So what we're going to be doing now is breaking down, understanding what we need to change in the calibration file so that the engine control module understands that the charge motion valve assemblies have been deleted, that we want to make sure that the status is in the open state and that it follow along to the map points 14 to 26, and it no longer references or calls on map points 0 to 13. This is essentially going to be uprooting all the programming that Ford has done in the engine control module. So there's some specific things we need to pay attention to. I'm going to make your life a lot easier. We're going to be using a template applicator file found in our course folder to bring in and overlay the update changes we need to make. And then we're going to go through what those changes are. And then we're going to move into using our Excel spreadsheet calculator and then talking about how we can actually visualize what's going on with the variable cam movement from the array tables that we're going to be updating, as well as the distance tables. Those two go hand in hand to the map points. We want to make sure that the variable cam movement is going to be logical. We'll find without the charge motion valve assemblies in place, if we have too much exhaust cam retard, we can actually start to get misfiring, or what it's felt like a misfire, and the misfire monitors will go through the roof on your logger. We want to make sure that we're not getting into the situation where we have too much exhaust cam retard. But in order to visualize that, we use the Excel spreadsheet. It is an invaluable tool, as you will find here as we go through the tutorial. So the first thing we should do here is open up a calibration file so we can start to reference a few things, and then we'll open up our template applicator file and apply it to the file that I'm going to be working with here, and then we can see the changes that need to be made in order to account for the charge motion valve assemblies being deleted. So I'm going to be opening up a 2017 Mustang GT calibration file. Any Gen 2 calibration file will work. So I'm going to go up here into the file open, and then I'm going to move in here to my HB Tuners Gen 2 Coyote course folder, the Mustang example file subfolder, and then into the 2017 Mustang file subfolder beyond that. So in here, I'm going to grab my 2017 Mustang GT file and click open, allow that to load here into my VCM editor software. So what we're going to do right now is jump here into our engine tab, and then we're going to move across into our airflow up here, and then we're going to go into our intake manifold runner control. Now, our intake manifold runner control in its stock configuration, so assuming you have a stock intake manifold, we'll find that we have the ability to call on the intake manifold runner control, or the charge motion valve assembly, to be open or closed. We can see up here under general, there's a switch and a position sensor. These are both enable. And if we're looking at our different modes that we operate in, so looking here, manual launch, best drivability, best fuel economy, optimal stability, we'll find that we have the ability to command the charge motion valve assembly being either open or closed. We see here high load position, designated by the load thresholds here in our tables, that's going to signify that the charge motion valve assembly is to switch from closed into an open state. But at low loads, so part throttle and idle, it should be in the closed state. Now, the reason why the charge motion valve assemblies are in place, they create a swirling effect for the fuel and air mixture coming into the engine. This enhances the combustion, and we usually get a bit better efficiency out of the engine. Now, if we have the charge motion valve assemblies in conjunction with the variable cam timing, and we go and retard the intake cam, and we retard the exhaust cam in conjunction with the charge motion valve assembly being in a closed state, for example, that will give us better economy, better drivability, better emissions output. So that's the reason why the charge motion valve assemblies are in place. So if we're going force induction, or if we simply want to keep things simple and delete them, we need to make sure that they are going to be open and that the state of what it's looking. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.